All right, so I don't know if you caught it Thursday. All the exams were finished graded, so check the keys, check the answers. Overall, it was pretty good. Not surprised. So check those out. All right, so we left off with steps. So the whole idea here, we violated our assumptions, and really, you don't have many options if you violate assumptions. You can do randomization tests, but as we start adding variables, independent variables, the whole randomization falls apart because we can't really ensure that our randomization procedures is actually capturing the coefficient that we're interested in. So the interaction that we're interested in. Really, we can do like like the complete interaction, we can do that, but anything below that becomes very hard. So I'm suggesting we use the stepwise, or the step function, and use information criteria for our model selection. So we introduce this step function here that automates the process. We give it our model, we set a scope, like an upper and lower bound, all right? And we're gonna leave direction equals both so it can drop terms and it can add terms back into the model, and we let it run, and R will automatically find the model that has the lowest AIC value. Now, this. So I have the college grad. This is where we left off. We started with our four-way interaction. All right. We checked our assumptions, and we started off with here. So we did our mod, null, and then we did lower, upper. We started at the top, and basically it drops the four-way interaction. AIC increased, and that's it. It says this is our simplest model. That is our complete full model. And say, okay, well that's fine. Our general procedure then is to start at the very beginning, at the null model, and work forward then, and see if we converge on the same model. If we get the same simplest model, then we end there. That is our simplest model. Then we start all of our Postdoc tests. So now I started with the null model here. Right? I had my lower, my upper, and when we run this, now it gets us to this point where it says, okay, this is actually our simplest model. So we don't have a four-way interaction anymore. And if we look at it, we get to this spot where the AIC is 4192.58, all right? 4192, 0.6, you could say. We compare it to all the other ones. This one is within 2. So maybe we need it, maybe we don't. General rule, though, is to always go with the simpler model. So if our AIC is less than 2, we typically pick the model that is simpler, but we do address it in our write-up. We do address it in the results in the discussion and say, well, we can't really separate these two models. So we're going to talk as if both of them are significant, or both of them are important. So this is different. This is a different simple model. So what happened? Well, there's this thing called local and global minimum. All right? And what happens is we caught ourselves, move forward here. We caught ourselves where we dropped a term, and instead of getting a decrease, so maybe we start right here. All right? Let's say we right here, we're at our local minimum. We dropped our four-way interaction, and it actually caused our AIC to increase. So R says, hey, we're going to stop. Well, we're here. We're trying to get to here. All right? So one way we can the next way that we then continue is to manually force our model past that point. All right? We manually force it past that point, and that's where this comes into play. So we go back to our full model and we say, okay, well, if we get past that local minimum, do we then converge on the same simplest model? So we're going to go ahead and update. Here it is, right here. we're going to go ahead and update our model. So I just made a model sim, remember that's where we left off. I'm just going to say almost full. So I'm going to update my full model. We're going to subtract out our 4-way interaction. I'm going to go back up to here. I'm going to regenerate this one, just so I can see that 4-way interaction, because that's it. That's how it appears. I'm going to subtract that 4-way interaction, create my almost full model, right? And then I'm going to use the step function. And now we're starting with almost full. Our scope is a list where we give it the lower is mod.null and upper is mod. I'm actually going to say almost. We'll try mod.full. So we'll let it kind of go back to its original spot. But in this time, since we started with a different model, we're going to remove terms and we're also going to add terms back in. So I'm going to run this and see what happens. And it ran and generated a bunch of output. So it started off with an AIC of 4219.2022. All right. When we added that 4-way interaction back in, we got this 4218. So we had a slight improvement, less than 2 difference. All right, kind of hard to see. But look what happens when we remove a 2-way interaction. It caused a much larger drop in our AIC. It dropped it down to 4214. So right now we know, okay, once we got past that minimum, now we're actually starting to simplify our model again. So stepwise kind of goes through all of the processes, keeping us updated along the way until we get to this part where our simplest model is 4192.58. And we have made it, and copy that. Actually, this LN. That's our formula for our call. I'm going to call it mod sim2. And I'm going to take out formula and create it. So now I have mod sim. I have mod sim. Yes, I have mod sim. And I have mod sim2. So let's do summary. Did you get it?
No.
Well, did you run it where we left off? Did you rerun everything to get to where we left off last time? Because that's probably what you need to do.
So mine had a different
What's that?
Mine had a different output.
Different output.
Like it didn't look like that. It looked like our very first is like have like every interaction and then like plus or minus different numbers.
So was it like?
It looks like that list that you just have.
Like
yeah,
this?
Like that, yeah.
So that is just the mod full. When we started it, when we run this, we start with our full model. R can't get past that local minimum because the AIC increases just a little bit. So once we did that, what I'm going to do is manually remove this interaction term. Because really, the difference is less than 2. So I'm going to force it and say, okay, I'm going to remove this term and then continue our stepwise selection. So that's what I did here with our almost full model. I did our update of the mod.full model, I want everything on the left, everything on the right, minus my four-way four-way interaction. And then once I had that, then I ran the step function. And I still listed mod null and mod full as my upper and my lower. So you can see that, yeah, it adds that four-way interaction back in, but removing one of those three-way interactions actually resulted in a larger decrease in the AIC. And now R is going to take that one and say, okay, I got past my minima. Let's now see where it gets us. All right. Now let's take a look. Now I did mod simp was going forward. Mod simp 2 was going backwards. All right. Oops. Let's run these together. So I get both outputs. All right. So I've got salary as a function of school plus time grad plus major time grad. You got different orders. I've got time.grad major or major time grad. Doesn't matter. Right? Terms in both of our simplest model are the exact same. So do you think we found the simplest model?
Yes.
What's that?
Neutral.
Yeah. This? Keep going. So yeah, we found the same simplest model. This represents our global minimum. This represents the global minimum. And we still have that question mark of, that last interaction term. Go up here. The school major, where it doesn't really, it's not a full 2 AIC units. So maybe it's important, maybe it's not. But leaving it out results in a simpler model for us. One less term to inspect. All right, questions? So we found 2 different models. Yep, this is what happened. We ended up at a local minimum. We had to force it above it. All right. So this is where we went. We kind of skipped it. We could manually specify forward or direction, but we already did this. All right. We already worked through it. The forward versus backwards, no big deal. So we're at here. So we have 2 best models, in quotation marks, if we go by the difference in AIC values of 2, right? They have the same terms except one has the school major. And we already said we can't really tell which one's the best, but generally speaking, we would go and do all of our post-hoc tests with this lower, 4192.6. All right. So we would report and do all of our post-hoc tests with this, but in our results, in our paper, in our presentation, we do address the fact that this other model was also just as good, just a little bit more complicated. All right, so now with the post-hoc test, we have to investigate, okay, what's going on? So we're taking this one, salary as a function of school, time to graduate major, and that time to graduate major interaction term. All right, now we want to do all of our post-hoc tests. We want to explain those relationships. We know that these have an effect on salary, but our question is, what is the effect? How does school affect our salary, our overall salary? How does this time to graduate and the major interaction affect our salary? All right, so what you have to remember now is if we did this method because we violated our assumptions, then we can't really do our basic like subsets with ANOVA. We have to proceed as if all of our assumptions were violated. Which means if it's just heteroscedasticity, yeah, we can start doing pairwise Welch's t-test or Welch's ANOVA. We can do bootstrapping and so forth. If it's normality or both, Then sometimes it's just randomization tests. Sometimes it's just going to do bootstrap confidence intervals. You just look at them and see, do they overlap or not? Do they capture the mean of the other one? So this is what we're going to do. We're going to go through it on this one. All right. So, and I'm just going to repeat again. If our main effect is not part of the interaction term, then we can just do a 2-piece postdoc test. If it's 3 or more levels. If it's 2 levels, you just look at the means. Right? You just look at the means and go with it. Right? You're going to analyze it individually. But if that main effect is part of the interaction term, then we have to take our subsets. So in this, school is not part of our interaction term. So if school is 3 or more levels, we can do 2-piece post hoc if all of our assumptions are met, right? On school. So after we account for all this rest, we can look at how does school affect overall salary, because that effect of school is consistent no matter what major we're looking at, time of graduation looks like, and so forth. But if we're interested in time to graduate or major, since those are part of our interactions, then we do our subsets. All right? So, schools, fortunately, is only 2-level variable. All right, we have public and private. So it's as simple as just looking at your averages and saying, yep, private schools result in higher starting salaries. And we're done. That's our postdoc test. That's our explanation. Pretty easy, right? Pretty easy. That's always what we're looking for. What about our interactions? We're going to start taking subsets. All right, so what I've done is made different subsets based on our time to graduate and our major. So fortunately, I did major as science versus non-science. All right, and for time to graduate, I did like less than 4 years, 4 to 5, and then 6 or 4 years. All right, so with the subset code, this is what I did. And we got our subsets. So we violated both normality and equal variances. So we can't really run our 2-piece postdoc. We can't run ANOVA. We're going to be restricted to using randomization tests for this. Now, I should say, kind of thinking ahead, if you had, let's say, 8 variables and you have like a 2-3-way interaction and you've got a bunch of main effects that are there, you can always take your subsets and then rerun your step function on the subsets to figure out which terms are important to keep in your mind. You can always do that. That's kind of next level stuff. So I'm going to make these subsets so that we can do it in R. So while you're doing that, I'll do it too. Did all your subsets work? Looks like you got them all. All right. We have some strings for like permutational ANOVA, permutational t-test, and so forth. But once we start adding multiple variables in our model, when we randomize our data, we need to make sure that our null distribution accurately reflects the null hypothesis that we are testing. So if we take a subset of, let's say, science majors, right, and we want to see, does time to graduate have an effect? We can't just randomize our entire data set, our entire subsetted data set, because now what we've done is remove the effect of private versus non-private colleges on the salaries. So if we're going to shuffle things, what we're going to have to do is shuffle within all of our private colleges and shuffle within all of our public colleges just to get to a null distribution that accurately reflects the fact that time to graduate doesn't have an effect. All right? So here's where another package comes into play, and it's the permute package. The permute package is going to let us do what's called restricted permutations, shuffling our data based on subsets. All right? So this is the idea with restricted permutation. And this is just kind of like an example to show what's happening and why it works. All right? So I generated just a simple group right here, where we have 2 factor levels with 10 items in each of them. And in those factors, I labeled them A and B, right? So I got A's and B's here. All right? I then have a treatment. And for the treatment, I have red, what I call red and blue. So let's say we have red light or blue light on plants. So we got plant A, plant B, and then we've got red plants and blue plants. All right? And what we have is within each of the A plants, we've got both red and blue light treatments. Within our B plants, we have both red and blue lights within our treatment. So far, so good? All right, if I just shuffled our data, we're going to shuffle. We're going to shuffle it so that in some cases, you're going to have unequal samples. So in our A's, instead of having 5 red and 5 blue, when we shuffle our data, we could have, let's say, 8 blue or 10 red, all in that sample, and that's not what we want. What we want is to randomly shuffle the red and blue within the A's and the red and blue within the B's. So what we can use is this restricted permutation, which is a little tricky to write and make work. All right, so what we would use is specify how we're actually going to generate our restricted permutations. And we're going to use this first line here. All right, so CTRL is basically your control. We're going to specify our subset, how we're going to kind of group our data before we do our shuffling. All right, and in this case, we're going to actually tell R how many permutations we want to do. The default is 999, which doesn't seem like a lot, but we can mess around and see how long larger sample sizes take. And then we specify our plots and our within. So the plots is what is the underlying structure of our data. All right, so we would say plots equal plots with a capital P. Our strata equals our group that we're trying to group on. All right. And then the within is how we're shuffling. So we're actually shuffling within each of our groups. And the type of shuffling that we're in is what's called a free type shuffle. That's what we did when we did permutational ANOVA, what we did when we did permutational t-tests and so forth. All right, so once we've set up and said, okay, we've got our grouping variable, and we want to shuffle within each of those grouping variables. And the variable, and we're going to shuffle within each of those grouping variables. Then we have to tell R to actually shuffle. So going back to here, our group here is the A and B. All right, that's the name of the variable that we are shuffling, or that we're grouping. That's our subset. We're going to shuffle our data freely within each of those groups. And we're going to shuffle that treatment variable, but it's organized based on our CTRL, our control. So when we do this, and this is just kind of like a example, we've got row indices because that's what the shuffle is going to do. It's going to take each one at each row and label 1 through 20. The first 10 are all of your A's. The next 10 are all of your B's. When we shuffle, what happens? We've shuffled 1 through 10 all within group A. We've shuffled 11 through 20 all within group B. And now we fixed the effect of A and the effect of B. We fixed that effect. That we didn't touch that, but we did affect how treatment. Now we're testing if treatment had an effect. So we can do this. All right. Quick overview. We're going to work through. You're going to see how it's done on our data sets. All right. So the R function is this. And I've highlighted what gets changed, which is that. That's the only thing in that line that gets changed. And we tell it our grouping variable. That gets changed. All right. And then our shuffle function, we can use shuffle or we can use permute. Permute is supposedly faster when it's used in a function. So using it as part of, let's say, the aggregate function, it's supposed to be faster. I don't know if it is or not. None of our data sets are ever that large or complex to have a noticeable effect. All right. So just as an example, I've got another script coming up. Oh, you do need your permute package. So it's already, on these computers, they should already be loaded. So I'm just going to make sure or I should say, they should already be installed. Personal computers, you may have to install them. So make sure permute. All right. So our control, school, is what we are selecting. All right? School is what we're selecting. So, go back here. How, we're going to leave it at 999. All right? Plots. All right, plots and plots. Again, haven't changed anything. Strata equals. Now I need my grouping variable. And the one that we're going to do is I'm going to use science. Oops. I'm going to use my science major data set. Good luck.
See ya.
Bet it's not as fun as this. School. All right, so we want to keep school fixed. All of our private colleges, all of our public colleges, we want to keep that fixed. So that's my plot. And then I need within, and I'm just going to type out, because it is the exact same thing. Note our capitalization. Note the capitalization here. So plots within lowercase w here, capital W here. And I can check it. It runs just fine. So, if I hit control and say, well, what does it actually do? It sets up the design of our permutation. That's what the permute package is going to look for. All right? So our individual plots are going to be school. That's what we're going to shuffle. That's what we're going to shuffle inside of. All right, number of permutations, 999. We're going to leave that fixed. Now, what we want to do is do our shuffle command or our permute. So our shuffle would be length of our variable. So dat.sci, $sign, we're in science, it would be time.grad. red, and control equals CTRL, because that's what we create. And when I run it, this is what I get. Yours is going to be slightly different. But this returns row numbers. This is going to return row numbers for us. And we then use the row numbers. Did it work? Yep. All right. So it returns row numbers. And if we broke it down, what you would see is that the row numbers that correspond to our private schools they all had the same row numbers. So like if private school was on row number 1, that row number 1 after we shuffle is still a private school. It didn't flip. If row number 100 was a public school, after the shuffle, it's still a public school. It doesn't flip. And that's the point of our restricted permutations, to maintain that structure in our data. Now, fortunately, this is all that you have to change, because I'm giving you a script that runs a restricted permutational ANOVA. So this kind of takes all of those row numbers that I'm showing you how it generated and plugs it into an actual ANOVA. All right, so you're going to see that I have this CTRL right at the top of the line, and we specify the grouping variable. And again, the grouping variable, make sure, yep, our grouping variable is going to be in the data $variable aspect, or in that form. Right. Now, that is a variable that is in our null formula. So this is the formula that will not be what we're testing on. Right? So for us, we're testing on time to grad. We were testing on time to graduation here. So school, that's in our null formula. Our null F, our null formula, is that null formula, which is a formula without our variable. So it's lm of y equals school. That's all it is. Because then our alternate, so this is our null, our alternate is that. Get this zoomed in so everyone can see it. So remember what I said was we went over our ANOVA and dropping terms and how the p-value when you drop a term is correlated to p-value of an ANOVA table. This is where this is where we were always going to get to this spot. So our null model, we left schooling, now we're testing this. We want to see, do we need to include this or not? All right, so our test var is a variable that we're testing our significance on. All right, that's going to be in the data $variable format. Our null formula is going to be written as an actual formula, using the L and Y as a function of whatever, and then everything else stays the same. So let me get to all. Make a new script. Remember that function script? How many of you actually made one? All right, so I've got one here. No, that's not it too. Where's my restricted notation? Don't tell me I don't have it here.
You don't have it. Oh.
I don't have it. I don't
Oh
have it.
my God, you guys should have one of these.
I know, I do. It might not be on the network computer.
Little piece of humble pie right there, didn't you?
I did. Let me see here. Actually, I will download it from Dropbox, and I will get it. Which, as I'm downloading this, I'm going to tell some of you guys. You guys should have told me that that new Marvel movie is actually a mini. I was so pumped up that Falcon and Winter Soldier, I thought it was a movie.
Did you?
It's not a movie.
Loki's gonna
No, they're 30
Yeah,
minutes of
Loki's
it, and
a
then wait a
miniseries.
week to watch even more.
That's their new thing
Just
now.
like the good old
Is
days.
the miniseries.
That's not their new thing. That's been Disney's thing. They're just
Marvel,
forcing it on
for
Marvel.
Marvel, that's their thing
They're
now.
literally just forcing it on Marvel now.
Okay, let's see.
Yeah, although I'm not entirely sure, but I believe the Hawkeye movie is now also just a series.
I don't mean that in any
What's
bad
that?
way towards you.
Haha, I told you I had it. I had it. All right.
I knew Disney.
Yeah, I know, I got numbers.
Yeah, I don't think this was working.
Yeah.
Yeah.
I don't know. I'm gonna try this again. I don't think this was working. So, restricted permutational ANOVA. I actually took a slight shortcut here. And what I'll do is I can copy this and post it as a text log to Blackboard, so you don't struggle to get it. Restricted permutational ANOVA. Actually. Send a copy of this announcement immediately. Alright, announcement. Post it, it's up. Copy it, paste it. May have to fix the quotation marks. That just came through for me. Go to Blackboard. Should be able to.
Where's it at?
Announcements.
How is it different from the one that, I can see that it's different, but
It is.
functionally what's the difference?
Data frame. How is it different? It's right here. So we did data $ variable function. What I did was do things a little bit easier. So we are testing, so the data frame that we are working with is dat.sci. That's what we worked with. So dat.sci. Now I can say my grouping variable is school. All right, and the formula now, salary as a function of school. And the test var that we are interested in is time.grad. So it just kind of saved me from having to always change data frame. If I just define dat as dat.sci, and you'll see it when we change the non-signage. So I got 10,000 permutations here. Are you guys able to like highlight and copy and paste from the announcement?
Yeah.
Make sure it works.
Mine's running.
Well, looks like it's running.
It's got the little stuff button on top, so.
I don't know. I was over in this debate one time. I never checked it.
Yeah, you had such a hard time with that. It was just your computer too.
My son had me get like, sit there and like, no, and just die.
This is probably,
Did I tell you what happened to me?
No, I just said it.
there it is.
There it was.
We got all of it in the house, and then, like, 12 hours.
So I got, mine came up.
So I never got it.
Took a little bit.
I literally
So I know time to graduation. Yeah, after we account for school, time to graduation has an effect.
Just one, okay.
Before it was giving me an error, but it wasn't actually coming.
L. Oh. Oh, hold on, change test bar. Yeah, that dot test bar, that is time.grad. So that $ time.grad. So what we've done is we've made sure that our school still has an effect. We kept that effect constant. So now we can isolate the actual effective time to graduation. So at this point, we can kind of go on and start to look at our subsets, right? Do our pairwise comparisons. I'm going to do this. Salary as a function of time.grad, data is dat.sci. I can look at this and we know that there's an effect. And the question now then becomes, is it a difference with all of them, or is it just between maybe our two extremes? Are two of these similar, and so forth? So now we would have to go on and say, okay, let's do our pairwise restricted permutational ANOVAs. I don't know if I have that on there or not. I don't know if I can't remember if that perm.ANOVA works, but it's same idea. So Postdoc Test for this then. Copy paste. All right, we got dat.sci. Whoops, actually, we'll leave dat. So we want our subset of dat.sci where time.grad is equal to less than 4, or time.grad is equal to 6, I believe. That's how I had written it. Is that right? No, 4 to 5. 4 to 5. Less than 4, 4 to 5. So now the subset's already written up here using the dat function, and it just kind of saved myself here. Everything's set up. Now we're just restricting our analysis just between these two, the less than 4 and the 4 to 5. And I would run it and wait for my p-value and save it. Then I run the next comparison, save the p-value. Then I run my last comparison, save the p-value, and then adjust our p-value. Which becomes d in time. At 0.0002. So So the first p-value is made. Go to the second one. 6p, 6 plus. 6
I got
plus.
an error.
Yeah.
Alright, where at?
What was the second line, but I didn't change anything in my copy.
You have to delete the space. Okay. Yeah, you guys can.
Yeah, it's not a comma there, it's that or type symbol.
zero every time. I'm getting zero every time. I don't know what they're doing this one, this one. What? Zero, zero.
Change me zero.
Yeah. Could be wrong. I'm only gonna peek out just zero. What'd you say? I'm only gonna just my peek on here.
How's your debt outside?
Very good question. Zero.
So that and that work? Oh, no, you got zero.
Yeah.
No, yeah, so if you got zero, something's not right. So, if you got zero, so you shouldn't ever get zero. You should never get zero. You should always get like whatever the smallest is. So,
Yeah, I think I got the smallest.
Oh, that,
That two.
yeah. You didn't change it. Because I get the same thing.
and just make sure that it's
Oh, just copy and paste.
No. Oh, DMX?
Yeah.
Yeah, the drug overdose.
Was it, did they confirm that?
Yeah.
Okay, it's an ANOVA drug. Or no, or alpha.
That day's
So
all
you did, your
dollars.
subset was debt outside, right?
I know that.
I'm not right.
I'm getting you there.
You got zero two?
No,
What is this?
Pretty-
That is row numbers.
small.
Very small.
Row numbers,
Okay.
row numbers, and that's how it works.
It's not.
Did you get zero still?
No, that's like for the next, that's for the next day, Nova.
No, no.
So 4 to 5, you're supposed to get like 0 points.
Well, it's I think it's a randomization test.
Well, because I got the same exact answer.
Oh.
Yeah, but it's not even a 0 point.
Mine's not right, it's still.
If it's just to the -5 though, that's basically the same as that. That's just 2, well, kind of. That's to the 4.
She does the same thing.
It'd be like 2 point whatever to the -4.
I know, but this was,
You got 0.
did you do strings as factors? You read it?
I've started to not understand.
I think so.
Yeah.
All right, so if you got a 0, it's off. So here's what I want you to do. Open up your console, right? So I'm going to do summary, dat.sci. All right, I did summary dat.sci, and this is what I get. All right, so I can see that I have 450 data points here. In the signs, I've got 0 for the non-signs. That's how it should be. What is your time.grad? Do you have 4 to 5, or is this 4-April?
4 to 5.
5-6.
Yours is 5-April. All right, so go ahead and reread that back in, and you'll have to remake your subset, or rerun that chunk with your subsets.
I still got zeros, but mine's 4 to 5. Read that side.
So,
Oh.
yeah, so I got dat is dat.sci. And then you also get a 0.
For both of these. Yeah. First one.
Rerun this again. If if you're getting 0, rerun this one again. And you did load the permute package, right? So rerun this again, and then what we'll do is we'll troubleshoot and see where it's going wrong. Because in the chunks, it's gonna make all of these. Let me rerun this, and we'll make sure that we are looking at everything again.
That is 0.
Yeah, I'm waiting for mine to finish up.
That outside should be a subset of college grad major science, right? We didn't enter that outside wrong
Yeah.
or something
Just like that.
like that.
Right? And then when you did your summary of dat outside, you got something like this. Right?
Yeah, just wrong.
All right. So
It looks
First
the
up.
same, but
go ahead and type in summary dat. And we should be the same as if we did summary dat.sci. Because that's the first step in our chunk. All right, did it work? All right, so now
same.
I'm going to type down CTRL and see what it says in my design. So I have the plots as dat $sign school. Right? Next up, we're going to do summary null F. So we created this null distribution, or this null hypothesis, which is just salary as a function of school. I'm going to do a summary, and we should get something like this, which is a summary of our ANOVA. So far, so good? All right. Now we'll check our T-bar. So I think what I'm just going to do is hit T-bar and hit Enter, and make sure that I've got this vector of time to graduate, right? And with the time to graduate, I have 450, 42, 43, 44, 45, 46, 47, 48, 49, 50. Yeah, 50. All right. So now I'm just going to do RES. This is my residuals. I'm going to make sure I get something like this, which is, RES. So we're just going line to line because we've been creating all of these. This is the residuals. All right. So we're good. And then that means if that's good, our next one is NOBS, capital N OBS. And it should give me 450 because that's how many observations we had. 450 observations. All right. Yeah, 300.
I got 300.
They're all.
But you might not be on you're on probably comparing 2, and that's why you're missing. You might be on a different,
My T-bar includes
if you ran a second.
It includes what?
It includes April
So you're
by the time,
comparing
which
4
is
and
not
4.
supposed to.
Yeah, that's not supposed to. Did you
When we read it.
did you manipulate this college grad file?
I don't think I did.
Did you? Should it been downloaded the CSV?
I wasn't trying to think yet. Yeah, but it says 5 to April in college grad. It's on there twice.
No, it should be. It didn't get reset. So
So I'm gonna re-download college
Oh,
grad.
what? Mine's 300.
Or your stream.
yours 300
Mine's
too?
300 as well.
Wait,
Is what we're
We figured it out.
Yeah, I think so.
I don't think, if yours worked, I don't think it.
Yeah, no, it was because Will said we changed.
Do you
Yeah.
length
File,
of red.
because that's not Pairwise, that's not.
Yeah, you can just highlight that length.
I feel, yeah.
Just run that'll run.
What did you get?
only what's highlighted.
I see, okay.
Right click it.
Is this what you
Extra highlight, do control enter.
No.
Not sure.
I got that.
So we need to figure out what's happening, why do we use it? So when you did your summary, did it show up as 450?
Yeah.
His Excel sheet is corrected
For some reason, as soon as I opened it up in
April
Excel, it's
5th.
auto-correcting to make it.
And then you resaved it as a CSV.
Well, I saved it, well, that's how it came up first. It didn't show me the right way.
Alex, did you
Made it-
download this Microsoft Edge? Is that why?
No. Never use Educate.
Is yours finished running yet?
Yeah, it says just 300.
All right, so go back to summary dat.sci. Go back and look. So some of you are getting 300 instead of 450.
My science is saying 450 for summary.
Your science, capital S?
Yeah.
All right.
Matt, did you run all the way through the Pairwise test?
Yeah.
Yeah, that's why your N is 300 instead of 450. Because with that, if you only ran the first model, would be 450. But after you're on Pairwise, you would only have 300 in there. Because you're only doing 2 variables instead of 3. Oh, okay. Oh, okay, I see what you're saying.
Yeah, but you just ran through this again, right?
Yeah.
Yes. So as I was there, that's not your pairwise.
So this is my Pairwise.
Oh yeah. So yeah, well you're getting a p-value.
Yeah.
You got a p-value.
Okay.
Some of these others are not. We're just getting zeros.
These other Yahoos?
All right, so we still get zeros, right?
Yes.
All right, so NOBS, did you fix that and you now have 450? All right, let's see what our FOBS is. Mine was 20.21093. Yeah, it should be. We haven't shuffled it yet. We haven't shoveled it. So your FOB should be the same value, 20.21093.
Okay, cool. Mine's 550.
So far, so good? Almost.
It doesn't have the data set fixed yet.
You can re-download it.
You just love
Yeah, and then I get.
Don't open it in Excel. Don't open it in Excel.
Don't open it.
So here,
Okay.
I'm gonna go back here where we've got the lecture, and we got let's see here, college grad. Just right click it and save link as. Save link as, and that'll download it as a CSV file. And save it, just override it and make sure it's still just called college grad, and that it doesn't have like a parentheses. So this right here is our observed F statistic. So now what we still have to do is create the null distribution of the F, all possible F statistics, under the assumption that our null hypothesis is true, which is that the only thing that affects our salary is school at this point. All right, so we should be there. Now, FRAND, I get something like that.
Mine says omitted 9,000 entries instead of 9,001.
Really?
And then the global environment where it says FRAND, mine says 1 to 10,000, or 1 to 10,001.
FRAND. Oh, yeah. So you have length, CTRL, n perm plus 1.
Yes.
Whoa. Oh.
This n perm plus 1.
Game changer. One.
Yeah. So
I mean, I was.
This- your numbers are going to be different because this right here is our null distribution. This worked for me. All right. This works for me. So now with this FRAM, what we're looking at is. Oops. This is our null distribution at this point. And our p-value is how many of these equal or exceed that 20 value, which none. The only one that we have is the one that we observed. But we're adding one more to that permutations to account for our actual observed one. All right? So, do you have 10,000 and 10,001? Because then our next step is to read in f_obs in the very first row. So f_rand brackets 1, I want f observed. And if I scroll up in this output of f_rand, that is our f observed value. 2.021093 e to the first. So there's our f observed. That's that value in our f_rand. All right, what does yours say? Do you have that value in your very first row? f_rand?
No.
Nope.
Yeah, but I think I found out for different. Okay.
I just noticed mine says 5-8. Or I don't want to.
It said I and C.
It says 5-8.
okay.
I'm not exactly. I'm hoping that we run out of time before I continue.
Let's see. Is that it?
I'm hoping so. Yeah, if you look
Yeah,
at
that's a Wednesday in that
this
project.
PowerPoint for after reference or I and C along something, that's different.
Or I'm just gonna use it as 5-8. Oh.
Is it the PDF that's different? Are you looking at the PDF?
I'm in the lecture presentation.
Which did you use
Ah.
that?
Yeah, you gotta use the one on the one that he announced on Blackwood. That was
That's the
different.
wrong one. How many of us did that?
I don't know.
So I'm gonna check that.
Cutting corners.
Check that.
That's what I got.
Skip ahead. We're gonna skip ahead. I probably did from the PowerPoint.
Scroll down. There it is. I got you. This was in the PDF. This. That's what was different. So now if you took that out and corrected it and did this in its place, get your p-value,
I did get you.
not a 0.
Yes. I got the same as you.
All right. So yours already worked.
Mine's good, but I have 5-8 on mine too.
Oh.
I'm pretty upset about it.
Right click save as.
Yeah.
All right. So kind of a learning experience that if you do get errors, if you get 1, if you get 0, you need to go back and double check. All right. And best way when we run these scripts, it puts all these values up here. Go ahead and go line by line, see what you're getting. Make sure you're getting something that's reasonable. All right. Make sure you're getting something that's reasonable. All right. That means then your time.grad would be 5-April.
That's what I'm gonna do. I'm not gonna re-download everything.
All right. So this is my second one. Second p-value. So yeah, that's and what was different added that dat so I can use subsets and not have to constantly fix it. So this is, whoops. Now what did I do? No, 4-5. That's what the issue is. All right. Let's get our last p-value here. Did yours work?
Yeah,
Still working?
Yeah.
Takes a while.
I got a 9.99, needed -5 for the first two bills. But I don't have to.
Do 1 over 10,001, 2 over 10,001, and 3 over 10,001. See what those values are. All right, got my p-values. Now it's just p-value adjust. And it looks like all of them are different. Time to graduate. So if you graduate in less than 4 years, you have higher salary than if it took you 4 to 5, which is still a higher salary than if you took 6 or more years. You can see it's kind of teased that. So at 611, what I want you to do is go through and finish this out for the non-science, which will add some time. All right? Yep.
I got my data set fixed, but it's telling me the lm.model is not found stuff.
Okay.
Function, and I rolled up, and it seems like that should be mod sim, because that's what was say here in the linear model.
Seriously.
My mind is
So you need to write that stuff, right?
Using linear model function.
Yep.
The model should be mod sim.
Yeah.
Right?
I don't, did you know what was going on?
Yeah.
Oh, really?
Okay, so that's yes for good.
I did that,
Giant one.
Yep, you gotta change your lower numbers, lower up is your mod dot null,
oh, yeah.
and then upper is the mod dot null. Yep, yep.
Lower, you didn't have to say that.
Yeah, remember, we found out you have to specify lower.
Yeah.
Yeah, it's good.
That's all I did.
Well, no, because you found it when we started with mod full, you stopped it, and we had to take all school into, right, and that gave us, right, so mod dot students. And when we worked forward.
Yeah, I guess you go, yeah, instead of that sign, you
Down
say-
to be diagnosed.
How does that make sense?
All the way over there.
Love it.
Is zero.
Yep. But with this, it did seek a line I
Different.
in,
What's different? What's different?
I in 2 colon length F rand.
That movie, man.
You sent my buddy to a tiger patch?
Yeah, 2 to length F rand.
So are you not supposed to get 9.99805 on the very first one on your run?
You might. So we've got 10,001. So that's the smallest p-value. So I got, when we look at this, I had 2 of my randomized vectors, or randomized data sets that exceeded F observer, that matched or exceeded. F observed. So I've got F observed, that's that 1 out of 10,001. That's the smallest p-value that we can get. So in my shuffle, I got 3, or I got 2 more of my randomized data sets that exceeded that. Is it possible? Yeah, we had 450 data sets, or 450 values. Out of those, so we had 150 and 150, the time.grad, which I'm going to guess. Dude, let's figure out what our sample size is. Aggregate of one table of school data side. All right, so 75, 75. So if you look, we had 150 on each of these that we're shuffling. We're shuffling 150 in private, shuffling 150 in public. You got that's how many different possible combinations, not accounting for replicants. We got a massive number. Okay, with our 10,000 barely touched the surface. Is the total possible combinations. So yeah, I bet if I ran it again, I might get a slightly different number. So let's try this. Less than 4. But it didn't change the fact. Once we adjusted our p-value, it didn't change it. Well, it did, but it doesn't change the conclusion.
Well, I got the exact same numbers for all 3.
Oh, okay. So for all 3, that probably isn't. No.
I bet you got 5-8 one.
Yeah.
I got what? I don't have 5 people. Well, they're not this one. So I got that. When I ran it, they were all the exact same.
Oh, for the p adjust?
Yeah.
They couldn't do that. Depends on, yeah, I mean, they couldn't do that. Because that's only one more value. Yeah, you ran. Yeah, that's how it'll work. Alright, let's see what I got. See, now I got it slightly different. Instead of getting the 2, I got that 2 out of 10,000. I know when we talked about it in undergrad stats, I said when you're dealing with these really small numbers, you can get slight changes. All right. When you start getting up to p-values of 0.5, 0.6, you're going to start seeing much wider changes based on randomization. But when you're at 0.05, the worst situation is to run this and get like a 0.051 or 0.049. Because every time you run it, you're going to sometimes you'll be above, sometimes you'll be below. And I told him, if you ever get that situation, come talk to me. We'll discuss how we can kind of figure out, is it significant, is it not significant? So, but you should never get a situation where you run it once and I get 0.05, and then you run it a second time, and now I get 9.99 e to the negative 16. That shouldn't happen. All right, so we're going to stop here. Work on the non-science. And then you can kind of play around with the next one. So we're going to have to kind of sample within the rest of our data set, just to confirm that the variable is significant.
Oh, wow. What a cocktail. Oh, my God.
Oh, my God. Boy.
Japan.
Plus one is the difference.
I don't know what you're doing with
Shut the face.
Regular old
dirt
yes,
nose?
like this.
Oh.
Yeah. Confirm
tried to do the no word.
Yeah. No task.
Oh.
That's close.
I'm sorry.
Don't.
Hey, look.
We're gonna go down here.
What about it?
We're gonna do that.
It wasn't bad. Yeah, we're done, yeah.
Yeah, we're kind of done too, but what is, like, how does y'all structure y'all? Like a regular proposal or
So
what?
it's still reading in.
No,
What?
we just like.
I fixed it. Shouldn't be doing that. Why did it work for the chunk above and not that
There was a little bit
one?
of background.
Well, no, it
information,
worked.
And then what we're gonna run, how we're gonna run our test,
Let's fix this.
And
Where
then,
is your reader in
like, what we're gonna need.
Well, it was just named college grad, so I didn't read it
Yeah,
in.
you got the background.
Yeah, it did.
Get any copy and paste?
Just not in
Oh,
it
there
there.
it is.
That, yeah, so the one in the chunk that's the old college grad, even though it's. has
We
the
probably
exact
could use
same
this
name.
supply.
Yeah.
Oh, no, I know what it is.
Let's fix this. So what we can do is this.
Delete that. Delete. This line is the old college grad, that's the one where.
Okay.
the Excel
you
file is your
Oh,
best
Did you
friend.
Thank
read it
you.
someplace else?
Well,
Save it
it
someplace
wouldn't,
else?
it wouldn't be in grad
I mean, we
stats.
have.
The new one is
to-
just on my
we have to do
desktop.
needy stuff, I guess we
Okay.
can still write it.
So
Yeah, so
I'll
I
let you
guess
handle
take
this,
away-
but we'll do this. College grad.
Yeah.
Okay,
Yeah.
cause we don't, I don't think we really need anything, like, I don't think we need her to get anything.
Right, or just like a list of like what you're gonna be using.
Okay.
Yeah.
Yeah. We're pushing a little over
Heck
two
with it.
pages though.
5-
She includes the
APR.
references. Maybe she
We'll
just
just
do
do
the
that.
references.
Okay.
Yeah, it's just
Let's scroll over.
background,
Yeah.
methodology, and like supplies needed.
So, okay,
See,
It's not that long.
yeah, so when you did your subset,
we maybe could
it
cut
didn't
out,
have two
you think
values.
we could maybe cut out
So you did
the
4-5?
because
Yeah,
of the expected-
it doesn't have
expected
4-5.
outcomes.
5-
Or we could cut out one of the
APR.
Yeah.
So now if we
Oh,
run
that's,
this,
yeah,
it's gonna get through.
that's sick. That's
I
just
agree.
dog
I just
I
I don't
couldn't
know
even
why I
correct
did
it,
that.
I couldn't even correct it here in Excel.
Yeah, that's.
Yeah,
It wasn't letting me edit.
No, because it,
Excel.
it automatically then changed it into date format, which will be, I don't know, I think Julian date format, it's a number then.
No flow, yeah, for
That's
sure.
sadistic.
No, I had to like,
It is.
I have some words. No, the under, one of the Cameron like rewrote one of my sections,
Alright,
and
thank
then I